Fala pessoal do SouJava. Deixa eu. Ai caramba, tinha que fazer. Beleza. Fala seu pessoal, tudo bom com vocês? Boa noite para todo mundo que está aí, essa bela noite. Vou trazer aqui meu amigo Sérgio, que é meu co-host aqui, meu amigão. Fala, Sérgio.
Estamos de novo aqui na atividade.
Bem-vindo, pessoal. Aí vocês, quem tiver aí, pode mandar as mensagens para dizer de onde vocês estão. Mas hoje nós temos um convidado internacional aqui, né, Sérgio?
Hoje temos uma presença ilustre aqui, um mestre do Java, developer
Java
advocate,
Master.
Java Master, developer advocate na Oracle.
O cara é gente boa pra caramba, a gente já conversou um pouquinho, né? Vamos trazer ele aqui então, Sérgio?
Vamos.
Então vamos lá.
Vamos lá.
Let's switch to English. So, deixa eu antes de mudar para o inglês, pessoal, quem tiver mensagens e quiserem fazer pergunta, tal, pode colocar em português. A gente vai
faz a tradução aqui.
A tradução, tenta fazer a tradução pelo menos, né? Se não conseguir, mas a gente dá um jeito. Tá ok? A gente dá um jeito. Galera, deixa eu chamar o cara. Let's switch to English. So, let's bring him.
Welcome to the stage, Billy Korando.
Okay.
Hey, glad to be here. Thanks for that introduction. I'm not sure. I did understand Java Master, and I don't know if I quite measure up to that, but I'll go ahead and take it anyways.
No, man, your presentation will be awesome, especially because you will bring a lot of features regarding Java 18. So it will be awesome. I already watched it, so I don't want to spoil you guys.
I want to understand what we have new in Java to use here.
Okay, so Pedro Lopes saying boa noite de Portugal. He say good evening from Portugal. So thanks again, and everyone, feel free to send us questions during the session. Billy's session looks like Billy will be help to answer you guys along the way the presentation. Okay. So, Billy, do you want to get started? Already?
Let's get started. Yeah.
Okay. Sergio, I will put on the backstage. So,
okay.
The shows is yours, man.
All right. Well, thank you very much for that introduction, and thank you for the invitation to be presenting at SouJava. Hopefully, at some point, I'll be able to present in person. Though, funny enough, I did do an in-person presentation last week, and I came back with COVID. Yay. Not yay. So, luckily, I'm feeling fine for the most part, but I do notice I do get a dry throat when I'm doing a presentation, and I might have some congestion. So, I might have to, just step away for a couple of seconds a little bit just to kind of handle some of that. But that said, let's get started. My name is Billy Korando, Java developer at Java at Oracle, and we're going to get into Java 18 and beyond. Please ask questions. In my experience with StreamYard, there's about a 4-minute delay or so between what I'm presenting and what you're actually seeing. But ask questions you can. I'll be following the comments. I can only read English, but Maximilian and Sergio have offered to translate from Portuguese if needed. But like I said, if you have any questions, please let me know. And yes, and that is where To Infinity Beyond is the reference with the to Java 18 and beyond. And you can find the slides of this deck here at this GitHub link. Some great information at these links, but we're pretty pressed on time, so I won't get into them. But definitely, if you want more information, check out these links and also like these Twitter hashtags. The agenda, we are going to be going through new language features that have been added between Java 11 and Java 18, then new runtime features, then we'll get into deprecation, removals, and other changes to know about, and then we'll take a quick peek into the future, though that might be somewhat shortened just because, well, we are pretty tight on time, and I do have a somewhat hard stop at the end of the hour. So we'll really try to get going here pretty quick. All right, the first thing I want to cover is text blocks. These were added in Java 15, And the JEP for it is JEP 378. Now, if you're not familiar with the term JEP, that stands for JDK Enhancement Proposal. And that means whenever there's a somewhat significant change being added to the JDK, the Java Development Kit, it goes through the JEP process. And I put these on here because these are actually a really great source of information about these features that will go into more depth than I have time during this presentation. And you can find that by going to here, open, there you go. Open jdkjava.net, and JEPs 0 gives you the full list of the JEPs. And like I said, for text blocks, that was 378. And if you put that in here, that will take you to that specific text block. And this will give you, like I said, the summary, history, motivation, goals, and all that, and examples of its usage. So like I said, if there is a feature that you want a bit more depth on that I just don't quite have enough time to get into for this, definitely, check that out here. And that can provide a lot more of contextual information. So text blocks, again, are great for handling formatted or markup languages within your text. Sorry about that. Okay, I may have to kind of, it's not fully refreshing I'm seeing here, so I may have to kind of go back and do this just to fully refresh the screen. It may be a little distracting, but hopefully we can get through it. But for text blocks, we've all had to kind of at some point work with JSON, HTML, SQL, or something like that in our code, and it can be very a frustrating experience to work with. In this example, with a very simple JSON message, we have all of this markup in here. We had to escape the double quotes and all that. It becomes difficult to read, and it also becomes very easy to have bugs in it. Imagine if we wanted to add a new line to this, and it could be very easy to forget to add a comma or forget a comma or not have a comma in here or something like that, just because you're so distracted by like all these new line characters and all these escapes. Text blocks are simply two-dimensional strings. Here, this is one-dimensional, but now it's two. So, and within these triple quotes for a text block, so they're denoted by a triple quote, new line, and then a closing triple quote. Formatting requirements are preserved or at least relaxed. So like we don't have to do an escape on these double quotes. We don't have to have new line characters. We don't have to have like tabs in here. So basically if this was to be rendered out by the JVM, this is what the code, or this is what the string would look like. Basically exactly what's within the enclosing, there we go, enclosing triple quotes. Fundamentally, though, a text block is just a normal string. So if you wanted to call a string format in it and to have it replace values within it, that can be done just as well, like string formatted, like in this example. Also with text blocks, if you need to have everything printed out on one single line, as the last line of the character, put a backspace or backslash, and then that will ignore the new line return. And so if I was to actually print out this really long line here in the system print out, it would just be printed out as a single line, not as 3 lines seen here. So that's a way you can do that. Just make sure that you don't have like a space or any other white space character after this backslash. Then it will be it'll just be rendered as a backslash by the compiler. So the next item I want to cover is switch updates, and these were added in Java 14, and the JEP for this was 361. Now the JEP for this says switch expressions, and that is included within it. However, there are several more updates to switch just besides that, so that's why I refer to this as switch updates and not just switch expressions. Of course, again, as Java developers, we're all pretty familiar with this old syntax for a switch statement where we have our case, colon, and then some code to execute, and then we end it with a break. And this was done because switch followed what was done for C++ and C, where it had fall through by default. So this creates what's very visually a busy code. So, we just have a whole lot of structure because we have to have the break statement in there as well. So it makes it more difficult to understand what's happening within the code. And it, of course, makes it more error prone because here, maybe at some point you're doing some debugging or refactoring and you remove a break statement by accident, you don't realize it, and you push it to production, and all of a sudden now you have a bug because when you match on case 6, it's going to print out both, Friday and then Saturday, which is probably not what you're wanting to do, or at least not what you originally wanted to do with your code. So to kind of address this, now Switch also supports the arrow operator. And with the arrow operator, when a case is matched, only the code to the right of the arrow operator is executed. So there's no longer any fall through by default, so you don't need a break statement. So this makes this code much more compact, and just much more clear to read. You don't have to have a whole bunch of structure of breaks within it, and also consequently less error prone. You're not going to accidentally forget to add a break statement and then subsequently have a bug in your code because of that oversight. So I think that's also a big theme with some of these language changes, is that not only is a code often easier to read, but it's also less error prone. Something we also saw with text blocks, to where you're not so worried about having all these escape statements and formatting statements that can distract you from maybe introducing a bug like forgetting a comma in like a JSON message. But so switches can also now be written as an expression, like in this example where I'm returning or yielding a string out of this expression. Now, switch expressions must be exhaustive. So often that will mean that it will need to have a default case, like in this example of a switch expression. Expressions then must yield an appropriate type out of them. So, it had to be string or some subtype of string, not that there really is any, or it must throw an exception. Is there a question?
Hey, Billy. I don't know why, but I don't know if it's only on my window, but looks like the window was broken a little bit. But that's okay. It's working right now. Okay.
Okay.
Maybe the
Oh,
internet,
yeah, that's right. It keeps
internet
sometimes happening. I don't know why that happens. It sometimes happens with StreamYard. So I'll keep it a lookout for that.
Okay, great.
All right. Thanks.
Take it away.
All right. Sorry. Let's see. Let me go back to that. Yeah. So sorry. This is what the switch, this is what a switch statement looks like using the arrow operator, and then this is what a switch expression looks like using the arrow operator. Sorry about that, and thank you, Maximilian, for coming in to show that, because I wasn't paying attention. So going forward then. And so also with the arrow operator, if you need some sort of more complex behavior to happen when you match on a case, you can have curly braces and have an actual code block then that can then execute multiple statements. Here with an expression example, I do need to have that in with either a yield or a throw out of it. So in this case, I'm yielding Friday out of this a string out of this. Yield is only context sensitive to within a switch expression. So if you have yield somewhere else within your code, you're not going to get compile error because yield's not an actual keyword. You can write an expression using the old colon syntax if you want, and you would just have to have a case in with a yield or a throw, and of course it would still need to have a default case as well. But as mentioned, most of the time when you write a switch expression, you will need to have a default case. But in this example, I'm using an enum, and because I cover all the different values within this enum in my switch expression, I don't need to have a default. And then that would also work with the colon syntax as well. So pattern matching is going to become a very important story going forward in Java. And the first example of pattern matching is for instance of, which was added in Java 16. And the JEP for that is JEP 394. So again, it's an instance of isn't super often used, but I think it's probably something we all have used at least a couple of times in our careers, or maybe a few more depending on what you're actually doing. But pretty much what happens is like you may have some sort of reference type, or just like a variable where you don't know the actual type of it. It could be one of several types, so you then do like if instance of, in this case, a string, then you in the subsequent if block will then have some variable that is definitely a string, and then you have to do a cast from the variable that you were just checking before. It's redundant and it's kind of messy. And if maybe this was a bit more of a complex example where maybe I was checking to see if it's like an integer or a long or a double or something like that, you could kind of see the more weaknesses of this pattern. But I think we've all kind of done before. It's always a little bit annoying and messy. So pattern matching allows it to be where, okay, if this variable is a string, then assign it to this pattern variable. Now I'm a string. And this is pattern matching. You have a predicate, is this variable a string? And then a pattern variable that is then assigned to it when this is true. And then this pattern variable, it is what's called flow scoped. And that means it's only in scope wherever the compiler definitely knows it has been set. So in this case, that means it's only would be in scope within the evaluation block and then in the following if block. And to get a more concrete idea of what that looks like is it would be here. Now my string is in scope here and in the if block, but then it would be out of scope once we left that if block. Here it would be in scope within this evaluation, but then it would be out of scope the second we left it. And so that would also then mean, like here, if we did an R, well, now my string would not be in scope on the right side of this R operator because, well, by necessity, this would have to be false for this to be checked. And then also we do. So I think it looks like Luis is asking a question. Not quite sure what's being asked though.
Yeah, actually, he asking which version pattern matching is coming to Java.
So yeah, okay, cool. Okay, I thought that was maybe, but I wasn't sure. So yeah, it came in Java 16 for pattern matching for instance of, but there's going to be other examples of pattern matching being added to other features in future versions as well. And that's what we'll get into in the beyond portion of the presentation, where we look a little bit into the future. So yeah, and then yeah, if but so to get back to this, but now my string would be in scope to the right of an and operator because this would have to be true first before we would even check to this portion of it. And again, just to be a little bit weird, or just to show the constraints around the flow scoping, if I was to put a not here, then now my string would not be in scope within this if block, but it would be in scope within the else. And then if I was to put a not and then do a throw within this if block, then actually now my string would be in scope outside of the if block. Oops. There we go. The next item will be sealed classes. These were added in Java 17, and the JEP for that is JEP 409. So what sealed classes do, or at least the way I see the benefit of sealed classes, is there's a way of putting in the domain logic that we all kind of have at our organizations where, you may have like a transaction concept, and then from that there may be 2 or 3 different kinds of transaction types that all maybe reference that super transaction type. But there's no real way of really defining that, like there's these 2 or 3 different times a transaction types within your code, it's just kind of implicitly shown that there's only those 2 or 3 that are implementing that are extending it. But sealed classes actually allow that to be defined within code. Sealed classes allow a class to define which subclasses can actually extend it. So I have an example here with user, where user only allows guest, customer, and admin to extend off of it. When you create a sealed hierarchy, then those subclasses must either define themselves as final, like in the case of guest, non-sealed, like in customer, or sealed themselves, like in the case of admin, which then has its own sealed hierarchy, where in this case, super admin is a final class, and normal admin is a non-sealed class, where maybe we have even farther admin types. And so what this would look like in code is you would declare with your class the new sealed keyword, and then there's the optional permits clause where you have like the classes that can then extend off of user. And then these subclasses, in this case, admin, would be also a sealed class, or it would have to be declared as final for guest, or a non-sealed with customer. And a non-sealed class is effectively a normal class, but we just have that designation in there just to make it clear that it's part of a sealed hierarchy. And we'll return to sealed classes in just a moment as well. But first, I want to talk a little bit more about, first I want to talk about records. I think one of the most important new features added to Java since like streams and lambdas in Java 8. And they were added in Java 16, and their JEP for them is 395. The first and most immediate benefit that the developers will get from records is that it does significantly reduce verbosity. And so I know this code is a bit small, deliberately so, where, maybe we have a method where we're doing some data transformation and we just need a class that kind of holds some of this data. And it doesn't really make sense for this class to be outside of this method. Now, to define a, oh, great. Thank you, Ricardo. That means a lot. Yeah. Sometimes examples are very abstract, and so I try to make it a little bit more concrete, at least, going back to my experience. So I'm glad that helped. But yeah, so for records, maybe you have like a throwaway class that you just need just to hold some data in, and it would only make sense within this method. But to define a class, even a simple one within a method, it becomes extremely distracting because it can just take dozens of lines of code to define even a simple class. With records, though, we can define this all in a single line, and that's just because records also have several constraints on them. So with a record, though, the goal of them is to be a transparent, and actually, that was all broken. So we can define the record in a single line where we just say record, the new keyword record, or no, not keyword, it's a reserved type also, so you could actually, I think, have record as a type, but you wouldn't want to do that because that'd be pretty confusing. And then you would then define the components of the record. So these are called components, which then become the fields of the resulting class. Let's see. So it looks like records want to be used, but why would you use them instead of Lombok? Is that basically what it's?
Yeah. Actually, Luis is asking if records will kill Lombok usage.
So not necessarily. So with a record, for one thing, like a record is designed to be immutable, whereas that isn't necessarily the case when it comes to the classes generated by Lombok. The classes generated by Lombok can be mutable, like they can follow that Java Beans pattern of having getters and setters. So if that's what you need, Lombok would still make sense. But certainly if you need an immutable class, then there will be almost no reason to use Lombok instead of records. Or yeah, there would be, yeah, you would never really want to use long block instead of records. And now, small part because records are actually built into the language, and as a result, can have certain features that you can't get from a long block class, even if it has the same immutable behavior with it in theory. And that's because with a record, the JVM would understand that. Its record or superclass will always be record, and it can't be anything else. It can't be extracted, extended, it can't be abstracted, and can't be final. You can't also declare any instance field with a record. And when you do this, also, then the benefit you get from this is that Java will generate the accessors, hash code, toString equals are automatically generated for you. With the accessors, it's not following that Java Beans pattern of like get first name or get last name. It's just using the name of the field, so it'll just be first name and last name. Also, a lot of these default implementations can be overwritten as you would like. But also another benefit of records is that they address a lot of issues with serialization because I don't want to get too deep into it, but with serialization, there's a bunch of magic methods with them that are called, and they effectively get around the constructor that a class would normally go through when it's being built. But that's not possible with a record because it has to have a canonical constructor that's always called. So there are also other benefits like that to records. So would it kill using long block in all instances? No, but probably in many. But again, like it comes down to what you're actually looking for your class, your data class to do. But yeah, so let's just say also like I wanted to override the default implementation of toString. I can do that here in this example if I just wanted to have it print out something different. And then also, these are fundamentally just classes. So if I wanted to add another method to it, I could also do that here with toJSON as well. Yeah, great question though, Luis. The last thing, and going back to sealed classes then, is so records, they can't extend another class, but they can implement interfaces. So if you do want to create like a sealed class hierarchy with records, you could do that with an interface, and in this example with this sealed interface. And I also mentioned, or maybe you caught it earlier, how the permits clause, it's optional. And it's optional in that if you define other classes in the same source file as a sealed class, the compiler will implicitly understand those those classes to be the only valid classes within that sealed hierarchy. So here, I don't need the permits clause because the compiler will just assume that admin, guest, and customer are the only three classes that are allowed to implement user. The last new sort of code feature is code snippets for JavaDoc API. And so what this allows is this creates a new snippet tag where you can put code within the snippet here within the braces. And this code then can be validated by the compiler, though this isn't done by JavaDoc, but it could be done by third-party tools and libraries. You can also reference external files as well, and also even specific regions within the file. And there's also a couple of other tags, like there's highlight, which you can use to like bold or italicize some string or some part of the code within that line. You can also use it to create links or to replace code as well. But this would be very useful for when you're using like a shared library, or if you're like a library or framework developer. So next, I want to get into some of the new features and runtime features and improvements. The first thing I want to talk about is class data sharing. And so class data sharing its history goes back to JDK 5, but pretty much what happens is whenever the JVM starts up, it loads some classes off of the file system. This can take and every time it does this, it's kind of doing this same process over and over. So obviously, doing the same thing over and over, there's opportunities for optimization. And a way to optimize this is to create a pre-processed shared archive of all the classes that JVM needs to load. So initially, this was only for core Java classes, but then in JDK 10, the new application CDS was added, which allows a shared archive to be created of your actual application classes, which allows the class data sharing to be much more beneficial for larger applications. Because if you were to do like a hello world application, class data sharing like only shaves off a couple of milliseconds off the startup time, but you wouldn't really notice that in like a real world application. But what class data sharing does is allows you to, our application class data sharing allows you to do is also create that shared archive that includes the files from your application. And so this was made even easier with dynamic application sharing, to where it only took as a two-step process. One step where you add in this JVM argument, archive classes and exit. You give the shared archive name. And so yeah, records are similar to a data class in Kotlin, but data classes in Kotlin, because they're not like a feature that's actually built into the Java language itself, can't enforce like the same type of invariance and immutability that records can. So they're similar to it, but they can take it a step farther because they're actually built into the underlying intrinsics of like the JVM and the JDK. But yeah, it's a similar concept. But AppCDS, so this will create a shared archive that once we kill this Java process, the JVM will generate a shared archive. And then on the subsequent startup, we reference that shared archive and then our application. And this can save 10 to 20% off your startup time, though that will vary depending upon what you're having on startup. If at the startup, you're calling out to some sort of database, that's going to take up a lot of your startup time because you're making some sort of like HTTP call happening there. So this is something to keep in mind. Another thing to keep in mind is this archive is memory mapped. So if you have multiple JVMs running on the same host and they're pointing to the same shared archive, there can be a pretty significant memory savings involved. I think I ran it with Spring Boot, and like it saved like 50 to maybe 100 megabytes off of memory because it's all using the same shared archive. And one last thing with the shared archive is it has a simple fallback to where if the JVM can't find the class that it's looking for in the shared archive, it will just fall back to trying to pull that file off of the file system. And so what this can mean is that if you're using a similar tech stack across your organization or within your team, you can really probably just use the same shared archive instead of having to create a shared archive for each application. So that way, if you're just all using Spring Boot or all using Quarkus or all using Micronaut or whatever you might be using, just create one shared archive, at a time for it, and just kind of share it between all those applications using that same tech stack, instead of having to create and manage a bunch of different shared archives. Awesome. Okay, it's great. It's great to see some people are actually using it in production, and we would love to hear back our feedback. I was actually talking to the AppCDS team pretty recently, and they don't get a whole lot of feedback at times. So if you're using it and you're ever running into issues or anything like that, definitely let us know. We would love to hear more. The next is the Z Garbage Collector, ZDC. Added in Java 15, it had several rounds of experimental preview before that. It's a fundamental redesign of garbage collection. It's currently single generation, but it's hopefully going to become multi-generational in the future. It's all the goals of it was to be ultra low latency and ultra scalable. So it tries to keep it to, or it almost always keeps it to under it targets it to be under 1 millisecond pause times. So it's really good for using it within a web setting to where you want as fast a response as possible. Now, the possible trade-off on that is in throughput. I'm not necessarily saying slower, but that is kind of some of the trade-offs that, focusing a whole lot on latency could mean a little bit less throughput potential. But definitely it's worth checking out. It's not, it's a full production feature. To use it, just turn on plus use ZDC and then, set your heap size and then turn on verbose GC logging just to see really what's happening inside your application. The next, I think this is something all Java developers will be very happy about, is helpful null pointers. They were added in JDK 14 and the JEP4 is 358. And simply put, it's just going to save us that heartache whenever we get those annoying null pointers. And then there's like in a line where there could be multiple variables that could be null. Now you'll get more information as to what was actually null and not to say an error occurred on line 7 or null occurred on line 7. It will actually say which variable was null. So that will make tracking those down just that much easier. ARM Architecture 64 support is now across all operating systems. So if you have one of those super fast, cool new M1 MacBooks, Java will be just that much faster on it when you're using it. Mac OS being the last major operating system to support it or to have support for it with JDK 17. Windows was added in JDK 16 and Linux all the way back 2017 with JDK 9. And the last, or I think this is the last one, is a simple web server. This was added in JDK 18 and the JEP4 is JEP408. And what the simple web server is just allowing ability to serve up static files with the absolute minimum of ceremony involved to where, now you can just say web server and then from the directory where you executed that command from, it will now start serving those files and it will be at the loopback address of 127.0.0.1 port 8000. The simple web server can only support HTTP. No, HTTPS is supported, and that's not a planned feature in the future because it is supposed to be for testing purposes only. MIME types are automatically configured. So if you had like an HTML file in there, it'll be rendered as text HTML, Java as text plain. If you had a JSON file, it'd be rendered as, text JSON. But you can configure this as well by configuring this class to map it. If you want to have Java rendered as HTML for some reason, you could do that. There are also other ways to configure the simple web server. The -p could change the port number, -b the binding address, -d for the directory. This can be a remote directory, and also you do need to provide the full path of the directory. A relative path won't work. I think they did that because they just want to make sure people know which path they're putting up to be served. And also you can change the output as well. The default is info, but you can also set it to verbose. Of course, also with every release of the JDK, there are a lot of performance improvements. Some small, some large, and some can be very specifically impactful. But yeah. So I took the exact same binary. I built it in Java 8 of Spring Boot Pet Clinic app 2.5.0. And so when I ran it on my machine, MacBook 2018, so it's still an Intel, it took about 5.25 seconds to start up, and it used about 673 megabytes of memory. When I ran that exact same binary, just Java, the Spring Boot Pet Clinic app jar, it took a little under 5 seconds to start up, and it used well under half of the memory. When I did it in JK18, slightly faster. Of course, this could just be a simple measuring noise. And it used slightly more memory, which I was surprised about. I thought it would have been less because of some supposed changes. But again, this is a very simple example. But with every release, again, there's both small and large changes being added. And they start to build up over time. Certainly between Java 8 and Java 17, there's a pretty substantial performance improvements that have been added. And, with more rigorous performance testing, you can probably really see it. But ultimately, it doesn't matter because it's always going to be very much specific to how your applications are designed and the uses of it. Just to say that there is a lot of performance improvements. All right, let's get into deprecations, removals, and other changes to know about. So we have about 20 minutes left. Security Manager and Applet API, have been marked for removal. Applet API was originally marked for deprecation in JDK 9. Now it's marked for removal. Fundamentally, Security Manager was just very complex to use and was rarely used. And also one of its primary use cases. Yeah, it's a very significant memory savings for sure. It's pretty easy to sell a 50% memory reduction. Security Manager, one of the primary use cases it was needed for was for applets when you were bringing in this external code to run within your JVM. But applets just aren't really used anymore. That's why they're being removed. And how we all run how almost all Java applications are really run is that they're built on on trusted hardware and then deployed, either into embedded machines where nothing else is going to be running, or we know all the things are going to be running on it, or, they're deployed out on servers. Any third-party code we're running, those are brought in at build time and can be statically analyzed for any sort of security issues. So fundamentally, the Security Manager was just no longer needed, and there was just a very high maintenance cost when it came to supporting it. Also, if that has been removed, in this case, these things are outright removed, is a Nashorn JavaScript engine. Just fundamentally, just JavaScript, it wasn't meant to run on the JVM. That's part of the issue. But you can still get access to the Nashorn engine. It's no longer packaged as part of the JDK, but you can go to OpenJDK Nashorn on GitHub, and it's actually still there, and it's still receiving a minimal level of support. The CMS Garbage Collector concurrent mark sweep, it was just replaced by the G1 Garbage Collector, which became the default Garbage Collector in JDK 9, and so subsequently the CMS Garbage Collector was obsolete, and so it was removed in JDK 14. So starting back with JDK 9, with the introduction of the Java module system, was this start towards strongly encapsulating JDK internals. And now we're really starting to see that take shape by having strong encapsulation by default, with being the case with the JDK 17. No longer thank you. No longer can you use illegal access permits to turn off the module system. But there are still some critical APIs like sunMISC unsafe still available to be reflected into. But now, if you do need reflective access into a module, you don't have access to it by default, you will need to either use add opens at the startup time or add opens to your jar manifest. So I focus very much on the JEPs because, well, that's the most significant new features that are being added to the Java language. So, of course, that's why I would focus on them. But one thing you definitely should check on as well, actually, you should have just kept it up here, is something that's been added to the Java doc is this. Why is it not showing? There we go. All right, cool.
Billy.
Yeah.
Billy. Maybe I don't know if your dimension of your window is so big. Maybe that's the reason why those things are failing to render.
Oh,
but that's okay. Go ahead. I think
okay. No problem. All right. But there's this new tab that's been added to the official Java doc, and it's even part of the Java doc yourself. that you can use as well. But it shows like new API and stuff that's been added to the language, like new classes, new methods, and things like that. And this is very useful to see because there's certain classes, like particularly stream and string, that have had a lot of new methods added to them that can greatly increase their usability. And there's other ones as well. So definitely check this out as well. I just don't have time to cover all these because, well, only have about an hour to cover all this generally with this presentation. All right, let's get quickly into the future as well. So, as I mentioned, pattern matching is going to become a very important new concept within Java going into the future. The next example of pattern matching that's going to be likely added to the JDK is pattern matching for Switch. It's currently in preview level 2 for JDK 18, and it's likely going to be in preview 3 in JDK 19. So what pattern matching is, again, we go back to what we did with pattern matching earlier. We have a predicate, a match. We're going to match on a type, in this case, integer. So, match on integer. And if this is a match, then we assign it to the pattern variable of I. And then I will only be in scope to the right of this arrow operator. And we can see how this can be beneficial here in this next example where I'm using guard patterns. And this is the new syntax that was added with the third preview of pattern matching for Switch, where if we have a guard pattern, if we want to do additional checks on the match of the pattern variable, we can do it here where we can say, okay, I is an integer, and if I is greater than 0, and you can and you can divide it by 2, then it's even, and I'll do something with that. If I isn't greater than 0, and it's not divided by 2, then it's going to be odd. But what's nice is because of how pattern matching works, I don't have to arbitrarily come up with like new variable names for each of these. I can just use the same variable label, and the compiler knows these are all separate instances of this variable. Pattern matching for Switch can also handle nullability. So if you need a null case, you can actually also handle that now as well with the pattern matching for Switch. Pattern matching for Switch can also read a sealed hierarchy. So I talked about earlier about the only case where you would not need a default case for a switch expression would be when switching over an enum. Now, if you had a sealed hierarchy and you covered all the different types within that hierarchy, then you would not also need a default case. And what's also nice is if we were to update this sealed hierarchy, or maybe when I just initially wrote this switch expression, I didn't cover them all, this will result in a compiler error. So this is, again, an example of how some of these new language features are making the Java code safer. Record pattern or pattern matching will also be coming to records with JEP 405. And hopefully this will be in JDK 19 as well as a first round of preview. And so what record patterns allow us to do, one thing I didn't cover about also earlier with pattern matching is it also safely handles nullability. So like right here, I'm having to do a bunch of null checks as like, okay, I have a rectangle and I want to make sure that the rectangle isn't null so that I don't get a null pointer error before I try to reference a field within it. So pattern matching, like with instance of pattern matching, for rectangle to be an instance of the class rectangle, it can't be null because otherwise it couldn't be instance of it. So it also safely handles the null case as well. And then with record patterns, I can just directly pull out fields from that record by just referencing them. So in this case, by position. So here, like I'm pulling out the 2 instances of color points from a rectangle, like the upper left and lower right here. And it could just farther go down to where really instead of having to do all these checks and getting into it like I did earlier, I can just directly drill down to the point of really what I want to get is this field, and then to print it out. So it's just reducing a lot of structure around code, which again also can reduce the issuance of bugs like accidentally hitting a null. I guess earlier Maximilian may be wondering, so like there was also array patterns, but that has been pulled out of the record patterns JEP, and I'm not sure where it's going to be implemented in the JDK, so I just kind of no longer going to reference that here. Definitely check out our early access builds. JDK 19 is already available in early access, as is Loom, Panama, and Valhalla, which are all very exciting. Loom is about adding virtual threads, which is going to really increase concurrency capabilities within Java. Panama is improving the native interfaces, and Valhalla is about introducing value types. If you can, we also have a new Oracle GitHub action, which has easy access to these early access builds. And it could be good to include like a weekly or nightly or some kind of build where you maybe bring in some of these early access builds and see if your tests still pass and see how your applications behave with it. Because that could be some great feedback for us to catch any sort of early bugs or other ways of how these new features could be improved. Also, I have code examples and a bunch of other information. But like I said, the link to the slide deck is here. Oops. And I'll copy that and give that to Maximilian and Sergio so they can maybe post it into the chat window. Also, the link to the JEPs. Also, when it comes to upgrading past Java 8, I know a lot of organizations and developers are having concern about that. And this is a really great article by a former Netflix engineer on how he accomplished that at Netflix. And fundamentally, what it was just upgrading dependencies. With that said, thank you. And yeah, if you have any more questions, please post them into the chat and I'll be happy to answer them.
Amazing, Billy.
Amazing. Thank you.
Yeah. Well, send us the link because I will share.
Yep, I just put that into the private chat. So yeah, post that out.
Oh, so. Okay.
I already put the links in chat too.
Oh, great. Thank you.
Great. Proficiency.
Pattern matching is going to become a very, Ricardo was mentioning, patterns is going to become very important and also very helpful going into the future. It's actually one of the things I'm most excited about. I know a lot of people are really excited about Loom and Valhalla, but I'm just excited about these cool new language features coming to Java.
Yeah, it looks like Java cares about security and something like that, and maybe that's the reason why this kind of decisions is so huge to decide. Am I right? So
yeah. When you have a user base as big as Java, security is always something very important to consider and think about because a lot of organizations run on Java.
I think security is the first one, and second one, performance.
Yes.
And we have a lot of improvement of performance in these evolutions of Java. It's amazing when you start using in your product environment and see this the memory and startup is slow memory, slow footprint, slow startup. Only by updating the version of Java.
No, that is amazing. And it's also one of the amazing things is like you also don't necessarily need to recompile your code to do that as well. It's not like, oh, okay, I'm upgrading, many cases you're going to need to anyways because you're upgrading dependencies and stuff, but you don't have to. It's like, oh, okay, this code worked perfectly in Java 11 and there's no reason if you don't have to recompile it to run it in Java 17, then you don't need to, which it can also be nice as well. Someone was asking, can you connect on LinkedIn? Yeah, feel free to. I'm not on LinkedIn super often, so if you send me an invite and it takes me a little bit to get back to you, don't take it personally. I can just be a bit slow in accepting it just because I get a lot of those invites, and so I'm just not on LinkedIn super often.
Okay. So Ricardo is asking if you can talk about a little bit about the Vector API, if you have some knowledge.
Unfortunately, I can't. Yeah, it's sorry. Like, I know a little bit about it, but I really I can't provide any meaningful insight. Sorry.
Uh, any spoiler yet? Am I right?
Well, yeah, exactly.
That's
Yeah,
okay. That's okay. I have a little question for you,
yeah.
Billy. And about the IoT ahead of time compilation.
Uh-huh.
Do you have some? Do you have some? What do you think about this movement that Java is getting with this cloud situation right now? Because we know that Java gets a little time to start up, but with ahead of time compilation, we can improve this thing
Yeah.
in
Yeah,
seconds.
and so
Have some.
that's primarily within the Graal VM, which I don't work with a whole lot. But yeah, I mean that's obviously very important, particularly if you're trying to do serverless, where you need to have an immediate, like as close to instantaneous startup as possible, because obviously if the user is calling out and it's taking even 2 seconds to get that startup going for that service, that's a very long wait time. Like for any of us, if we're waiting 2 seconds for our page to load, we quickly start hitting refresh, which then even further overloads our system. So obviously in those cases, having that ahead of time compilation and all that stuff is very important. Like I said, I don't work too much on Graal. We have some great Graal VM developer advocates, so I'll be more than happy to connect you with them and have them come to present at SouJava, because they could really actually provide some real deep insight on that, far more than I'd be able to.
Okay, so I must thank you. I saw your tweet as a special the ship of Java that you
Uh-huh.
record each Monday, if I'm not wrong. Am I right? So
Yeah.
it's so funny and it's fancy thing. So well, I got another question from Ricardo.
Uh-huh.
Do you have a preferred
Improvement.
improvement improvement added to the language, or one
Uh,
of that really we expect in the future?
Yeah. I think records, I think particularly records, once we get record patterns added as well, that's going to be something I think Java developers, as we kind of get our practices built up around it, it's going to find it really beneficial. Because like sometimes it can be very verbose and burdensome, as we kind of saw back here with my example, or the example that I borrowed from the the code that's provided, that it can be very annoying to kind of dig down to get to a specific field within your code. And if you're using records, and this can also probably help encourage the use of records as well, it can be very easy to eventually dig down to like some deeply nested field, and just directly pull out that reference and do whatever work you need with it. This is obviously much quicker and easier than this, and you also don't have to worry about null pointers as well. So records, and as we get more and stuff added to records, particularly record patterns, and eventually there could be some deconstruction patterns and destructuring patterns as well. I think Java developers are going to be really excited with that, because I just know there's been several times in my career where I had to do like ETL, exchange, transform, load, where oh god, it's just so much typing you have to do the getters and the setters and blah 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 blah. And I think in those areas, record patterns or records and all the features around them is going to make it much easier. And I think that's also something, I have this in another presentation where this is part of a specific goal, because as we were just kind of talking about with like the need for like having a fast startup time because you're maybe doing like a serverless function, or you maybe have like a microservice, or maybe not necessarily microservice, but otherwise like a smaller service that's not a monolith. You're operating at these data boundaries a whole lot more, to where you're needing to do a lot more data transformation. And that's where records could be really beneficial in being able to much more easily transform data into the needed shape for you. And that's also then where those patterns will also be much more powerful and helpful.
Very good.
Mm-hmm.
Awesome. So I don't know if there are more questions in the chat. So feel free, everyone, if you have some questions.
Mm-hmm.
But I must thank you, Billy, for
Absolutely.
the presentation. And I saw that you are facing that you improve your health.
Yeah,
you are a warrior, man. You are a warrior, because most of the people are lazy. They prefer to be resting, and you want to
prefer
keep your agenda.
here.
Yeah, exactly. Yeah. No, but thank you also, Maximilian, for reaching out before and checking to make sure I'll be okay to present. Because luckily it hasn't been that bad. But yeah, had this been a couple of days ago, that would have been a different story. Or at least I was much more fatigued and probably wouldn't have been able to present. But luckily, my condition improved to where wasn't an issue at all. So, and hopefully, sometime in the future, I'll be able to do this in person.
Okay, maybe in the future.
It will be an honor.
Yeah.
Yeah.
Awesome.
So, everyone, I must thank you, everyone. Clayton Franco. Okay.
Yeah. Thank you for all the questions, and thank you for the invite.
Yeah. I saw everyone. If you let's grab the. Okay. Yeah, that's it. Move it to your Java 18.
Exactly.
Yeah.
18.
Yeah. So, everyone, feel free to reach out. Billy, you send us the link. So
yes,
I don't know if let me. I think that if I write the message here. Oh yeah, your handle, your Twitter handle is showing up. So feel free, everyone, to follow him and watching his posts about Java, and stay tuned, because our SouJava is happening.
It's a busy channel.
It's a busy channel. Yeah, we have a lot of new events that's coming next week. Am I right, Sergio? So, Billy, I must thank you.
Thank you,
Sergio. You have. Do you have the last words, Billy?
No, but thank you again. Thank you again for the invite, and hope to see you guys again here pretty soon. And thanks again for all the questions.
Yeah, Sergio, do you have?
Oh, thank you for Billy. Thank you, Max, for asking me to help you again. And I'm waiting all of you who spending a lot of time with us today. It will be in the next time. We have a lot of amazing things being prepared for next talks.
Yeah.
Awesome.
And awesome, everyone. So be safe, and see you next time, everyone. Bye.
All right.
Bye.